For a GFCI providing single protection, meaning there are no load terminals, twist only the line-side conductors. In single protection, there are no load terminals on the GFCI. Twisting the line-side conductors helps to secure the connection and prevent loose wires. Rolling the conductors on the line side is not necessary for single protection. Here are the steps for single protection wiring. 1. Pigtail the line side conductors, which include the black, white, and green or bare wires. 2. Twist the pigtailed line side conductors together. 3. Connect the twisted line side conductors to the line side terminals of the GFCI. Rolling the conductors on the load side is typically used to identify the downstream circuits that are protected by the GFCI. This is helpful for troubleshooting and future maintenance. However, when wiring for single protection, there are no downstream circuits, so rolling is not necessary. It is important to ensure all electrical work is performed in accordance with the National Electrical Code, or NEC, and any applicable local codes. Always to energize the circuit before working on electrical components. Consult with a qualified electrician if you are not comfortable performing the work yourself. The purpose of twisting conductors is to create a secure mechanical and electrical connection. When conductors are twisted together tightly, it reduces the risk of them coming loose over time, which can cause arcing, overheating, and potentially a fire hazard. A good, solid connection also ensures reliable current flow. The NEC provides guidelines for making proper electrical connections. While it doesn't specifically mandate twisting in all situations, it emphasizes the importance of making mechanically and electrically sound connections. Twisting conductors before applying a wire connector or terminal is a common and recommended practice. Wire connectors, such as wire nuts, are designed to grip the twisted conductors and maintain a secure connection. The pressure from the wire connector helps to further tighten the connection and prevent loosening due to vibration or thermal cycling. Different types of wire connectors are available for various wire sizes and applications. It's crucial to select the appropriate connector for the job and to follow the manufacturer's instructions for installation. Some connectors are designed for solid conductors, while others are suitable for stranded conductors. Using the wrong type of connector can compromise the integrity of the connection. Torque is an important factor in making secure electrical connections. Over-tightening a terminal screw can damage the conductor or the terminal itself, while under-tightening can lead to a loose connection. Torque screwdrivers or torque wrenches are available to ensure that terminals are tightened to the manufacturer's specified torque value. Using a torque screwdriver or wrench can help to prevent connection failures and improve the overall reliability of the electrical system. In addition to twisting and using wire connectors, other methods for making electrical connections include soldering, crimping, and using mechanical connectors. Soldering involves joining conductors together using a molten metal alloy. It creates a strong, permanent connection with low resistance. However, soldering requires skill and specialized equipment. Crimping involves compressing a connector onto a conductor using a crimping tool. Crimped connections are widely used in automotive and industrial applications. Mechanical connectors use screws, bolts, or clamps to secure conductors together. They are often used for larger conductors or in situations where soldering or crimping is not practical. Grounding is an essential aspect of electrical safety. A proper grounding system provides a low impedance path for fault current to flow back to the source, which helps to trip a circuit breaker or GFCI and prevent electrical shock. Grounding conductors should be securely connected to ground rods, metal water pipes, or other approved grounding electrodes. The size of the grounding conductor must be appropriate for the size of the circuit conductors. The NEC specifies the minimum size of grounding conductors based on the ampacity of the circuit. Bonding is the process of connecting metallic parts of an electrical system together to create a low impedance path for fault current. Bonding helps to equalize the potential between different metal parts, which reduces the risk of electrical shock. Bonding conductors should be securely connected to metal enclosures, equipment frames, and other metallic components. Electrical panels, also known as load centers or breaker boxes, are the central distribution point for electricity in a building. They contain circuit breakers or fuses that protect individual circuits from overcurrents. Electrical panels should be properly labeled to identify the circuits they serve. It's important to maintain adequate clearance around electrical panels to allow for safe access and maintenance. Arc fault circuit interrupters, or FSIs, are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. FSIs detect the unique characteristics of arc faults and trip the circuit breaker to interrupt the flow of electricity. FSIs are required in many locations in residential buildings, such as bedrooms, living rooms, and dining rooms. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, utility switching, or other events. SPD divert excess voltage to ground, preventing it from damaging sensitive electronic components. SPD are available in various types, including whole-house SPD and plug-in SPD. Electrical codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or ALL. These codes and standards provide guidelines for the safe installation and operation of electrical systems. It's important to stay up to date on the latest codes and standards to ensure that electrical work is performed safely and correctly. Regular electrical inspections can help to identify potential hazards and ensure that electrical systems are in compliance with applicable codes and standards. Electrical inspections are typically performed by qualified electrical inspectors who are certified by a recognized organization. Power quality refers to the characteristics of the voltage and current in an electrical system. Poor power quality can cause equipment malfunction, overheating, and reduced efficiency. Common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Electrical safety training is essential for anyone who works with electricity. Training programs cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment, or PPE. Completing an electrical safety training program can help to prevent accidents and injuries. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Following lockout/tagout procedures can help to ensure the safety of workers. Personal protective equipment, or PPE, is used to protect workers from electrical hazards. Common types of PPE include insulated gloves, safety glasses, and arc-rated clothing. The type of PPE required depends on the specific electrical hazards present. Always inspect PPE before use to ensure that it is in good condition. Electrical testing equipment is used to measure voltage, current, resistance, and other electrical parameters. Common types of testing equipment include multimeters, clamp meters, and insulation testers. It's important to use the correct testing equipment for the job and to follow the manufacturer's instructions for operation. Working with electricity can be dangerous, but by following safe work practices and using the appropriate tools and equipment, you can minimize the risks. Always be aware of the potential hazards and take the necessary precautions to protect yourself and others. Remember to energize circuits whenever possible before working on them and to consult with a qualified electrician if you have any questions or concerns. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault. Ground faults occur when electricity flows through an unintended path, such as through a person's body. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. When wiring a GFCI for single protection, the goal is to protect only the receptacle itself, not any downstream receptacles. This is typically done when you only need GFCI protection at a single location and don't want to extend that protection to other devices in the circuit. In this case, you would connect the incoming power wires, also known as the line-side wires, to the line-side terminals on the GFCI receptacle. The line side terminals are typically marked with the words line or with arrows pointing towards the receptacle. The load side terminals, which are typically marked with the words load or with arrows pointing away from the receptacle, are not used in a single protection wiring configuration. The steps for wiring a GFCI for single protection are as follows. Firstly, turn off the power to the circuit at the circuit breaker. Secondly, remove the existing receptacle from the electrical box. Thirdly, identify the line side wires, which are the incoming power wires. These wires are typically connected to the existing receptacle. Fourthly, connect the line side wires to the line side terminals and the GFCI receptacle. Make sure to connect the black wire to the hot terminal, the white wire to the neutral terminal, and the green or bare wire to the ground terminal. Fifthly, cap off the load side terminals and the GFCI receptacle with wire connectors. Since you are not using the load side terminals, it is important to insulate them to prevent accidental contact with other wires. Sixthly, carefully push the GFCI receptacle back into the electrical box and secure it with screws. Seventhly, turn the power back on at the circuit breaker and test the GFCI receptacle. To test the GFCI receptacle, press the test button. The receptacle should trip and the power should be interrupted. Press the reset button to restore power to the receptacle. Twisting the line side conductors together before connecting them to the GFCI receptacle helps to ensure a secure and reliable connection. Twisting the wires together creates a larger contact area, which reduces the risk of the wires coming loose over time. It also helps to prevent oxidation and corrosion, which can degrade the connection and cause problems. When twisting the wires together, make sure to use the correct size and type of wire connector. The wire connector should be rated for the size and number of wires being connected. It is also important to use a wire connector that is specifically designed for use with solid or stranded wire, depending on the type of wire being used. Rolling the conductors on the load side is not necessary when wiring a GFCI for single protection. Rolling the conductors is typically done when you are extending GFCI protection to downstream receptacles. In this case, you would connect the load side wires to the load side terminals and the GFCI receptacle and then roll the conductors together to create a secure connection. However, since you are not using the load side terminals when wiring for single protection, there is no need to roll the conductors. It's important to note that electrical codes and regulations vary depending on the location. Always consult with a qualified electrician or electrical inspector to ensure that your wiring is in compliance with all applicable codes and regulations. Improper wiring can be dangerous and can lead to electrical shock, fire, and other hazards. When working with electricity, always take the necessary precautions to protect yourself and others. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and always de-energize circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. GFCI receptacles are designed to protect people from electrical shock, but they are not a substitute for safe work practices. Always follow safe electrical procedures and take the necessary precautions to prevent accidents and injuries. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. Electrical work should only be performed by qualified individuals who have the necessary training and experience. If you are not a qualified electrician, it is best to leave electrical work to the professionals. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or death. In addition to GFCIs, there are other types of safety devices that can be used to protect people from electrical hazards. These include arc fault circuit interrupters, or RFCIs, which protect against arc faults, and surge protective devices, or SPDs, which protect against voltage surges. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between two conductors, creating a spark or arc. RFCIs are designed to detect arc faults and quickly interrupt the power to prevent a fire from starting. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, utility switching, or other events. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. SPT divert the excess voltage to ground, preventing it from damaging the equipment. Electrical safety is a serious matter, and it is important to take the necessary precautions to protect yourself and others from electrical hazards. Always follow safe electrical procedures and consult with a qualified electrician if you have any questions or concerns.